The phase change diagram, or stair-step diagram as they call it sometimes, because it looks like a set of steps going up and then flattening out and going up again. We need to label these things out. It's got A, B, C, D. I'm going to start over here with the basic. We'll come back to A and B. Start down here with C. This is the simplest way to do it. We know the phases are solid, liquids, and gases, and that's the three lines that where we see increasing temperatures. All right, as we go up, the temperatures over here, and if I go from negative 20 up to 0, that's going to be my solid. From 0 up to 100, that's going to be liquid state. Okay, and if this was water, which I believe it is, that makes sense. At 0 degrees, we're in the liquid state because that's the melting point. As we come up here to solid, it melts at 0, and then it's here at liquid all the way up to 100 degrees, and then at 100 degrees where that boiling point is. So that's when it shifts over here to the gas phase over here on line E over here. In between the phases, in between solid and in between liquid, we have these flat lines. And so G right here is actually two things. It's freezing or melting. It depends on which way you're going. If I'm going from the solid to the liquid line in this direction here, that would be melting. If I'm going from the liquid back towards the solid, that'd be freezing. So that could be either one of those, melting or freezing. Up here where F is, where I'm going from liquid over to a gas, well, they call that's where we're boiling the water at, and they call that vaporization where it goes over there. Now, a lot of these diagrams, they would have going backwards, they call that condensation. I really don't like that term being used there. Vaporization happens at a certain temperature, whereas condensation, you're not going to have condensation at 100 degrees. Condensation is like evaporation. They're like the opposites of each other. They can happen at any temperature. It just depends on the amount of water vapor in the air. It's this thing called vapor pressure. For instance, if I had a glass of water, I don't need it to evaporate. I don't have to have it at 100 degrees. I can just sit on the table at room temperature. It will evaporate. Same thing with condensation. If you have a very, very, very humid air outside, the air is saturated, you can get it to condense with very little effort, much lower temperatures than 100. So I don't like putting, a lot of times they will put condensation up here. I just don't like it. Vaporization is fine though. That's where you're boiling the water at 100 degrees, and that does happen at 100 degrees. So F should be vaporization across here. These guys over here that mark the temperatures, well, these are the points. At 100 degrees, this is the boiling point over here at A, and then B would be either melting point or freezing point, or you could go freezing point and melting point. It doesn't matter. They're both the same temperature, 0 degrees. It just matters which way you're going on the line. If you're going from a solid to a liquid and it passes through that 0 degree mark, that's called the melting point. And if I'm going the opposite way, if I'm going, if I got a liquid and I'm cooling the temperature down, and it hits that 0 degrees, that would be called the freezing point then, because we're going from a liquid to a solid. And if I heat it back up and it passes through 0, that'd be the melting point. So it depends on which way you're going, whether you call that 0 the melting point or the freezing point, exact same number. Down here at the bottom, it says, what does temperature do during a phase change? Well, the phase changes are these guys here where they're melting and freezing, or where you have vaporization up here. And these lines are flat. And the fact that they're flat tells you temperature does not change during a phase change. If I look right here, we're at a solid. Well, right here it's a solid still. It's at 0 degrees, and as I'm melting, when it gets all the way over to the liquid line, at the bottom of the liquid line, it's still 0 degrees. That temperature has not changed. Same thing up here where I'm at 100 degrees as a liquid, and then I'll start to boil that water, and it's changing over to a gas, and it gets all the way over to this side, it's all the way a gas. It's still at 100 degrees. Temperature doesn't change during the phase change. Once the phase change is completed, then we can start to increase the temperature again. But that's an important thing. During phase change, temperature doesn't change. Any energy you add, say if you had an ice cube and you're adding the heat lamp to it, and you're adding energy to it, it's not, when you get to the phase change, it's not making the atoms jiggle any faster. It's not increasing the temperature. It's breaking those bonds they have with each other and getting them to let go of their hands so they can slide past each other, and that energy is used to change it from a solid to a liquid.